Okay, lesson 2 in this unit deals all about some very special right triangles. We're going to use the Pythagorean theorem and all of our geometry to help us learn about very special right triangles. Specifically, I want to learn about, oh, give me tools, this right triangle and the one that comes from this one. That's great. So the triangle on the left is what we call a 45, 45, 90 right triangle, because the two acute angles are 45 degrees and that's a 90. This is the 45, 45, 90, and when we say that, we mean all the angles are in degrees, right triangle. Because of this, we know that the triangle is isosceles. Both those sides are congruent. And we know that if these sides are, I don't know, 1, we know how to find the hypotenuse. The hypotenuse comes from the Pythagorean theorem. 1 squared plus 1 squared is x squared. And of course, 1 plus 1 is 2. And so x is the square root of 2. This is the square root of 2. Now that's an interesting discovery, because if the legs were some number other than 1, I'm coming back, don't worry, I'm coming back to that one. If the legs were something other than 1, let's say that the legs were 4, and I wanted the hypotenuse. Well, we'd play the same game. 4 squared plus 4 squared is x squared. And so 16 plus 16 is x squared. So x squared is 32. Well, now I've got to take the square root of 32. What's the square root of 32? It's the square root of, I went too fast. It's the square root of 16 times the square root of 2. That's 4 radical 2. And I start asking myself, maybe there's a pattern. Maybe, magic pen. Maybe 1 and radical 2, maybe that's just a set of ratios. Because this is 4 and 4 and 4 radical 2. If the legs were 7 and 7, the hypotenuse would probably turn out to be 7 radical 2. And that is in fact the case. So much so that if the legs are x and x, the hypotenuse is x radical 2. And that enables me, in a pinch, to say, okay, if this is a 45, 45, 90 right triangle, and the legs are both 8, what is the hypotenuse? Well, the hypotenuse is 8 radical 2. And similarly, if I have a 45, 45, 90 right triangle, and the hypotenuse is, 18, well, the 18 is some leg times radical 2, where x is the leg. So how do I get that? Well, that's 18 over radical 2. And somebody decided a long time ago can't have a radical 2 in a denominator. And so we rationalize that. We multiply top and bottom by radical 2. And what does that do for us? It gives us an 18 radical 2 up top. Radical 2 times radical 2 is 2. We've got 9 radical 2. So we can find hypotenuses if we know legs, and we can find legs if we know hypotenuses. which brings us to the other special right triangle. And the other special right triangle is the equilateral triangle, because if we drop a hypotenuse, not a hypotenuse, if we drop an altitude down, this is a 60-degree angle, this is a 30-degree angle, so this triangle on the right is a special triangle. Furthermore, let's pretend that all the sides of the equilateral triangle are 2. If all the sides of the equilateral triangle are 2, then this is 2, but this guy going along the bottom, he's only 1. And what does that mean for the altitude? Well, the altitude is going to come from 1 squared plus altitude squared is 2 squared. And so h squared happens to be 3, which makes this the square root of 3. Does that almost make sense for you? And so what does that mean for me? That means that if this guy on the bottom was an x instead, this guy on the altitude would be an x radical 3, and the hypotenuse would be a 2x. All of this, because no matter how I build that equilateral triangle, no matter how big I make it, the ratios among those sides will always be 1 to radical 3 to 2. And the biggest, big things that we should remember. The biggest side is opposite the biggest angle. Biggest side is opposite the biggest angle. And the smallest side, the x, is opposite the smallest angle. You can tell just by looking across from the smallest angle, you've got the smallest side. Okay, so in a 30, 60, 90 triangle, here's a 30, 60, 90 triangle. Here's your 30, here's your 60. This is 32. I want that. Well, I've got to remember that this hypotenuse is the 2. It's the side that's twice as big as the one that's opposite the 30. This is the 1 in the 1, 2 radical 3 right triangle. This guy here is the radical 3. So if that's the case, then the x that I want is half as big as the 32, and that's just 16. Similarly, if I've got a right triangle, it's a 30, 60, 90 right triangle, and this is 2 radical 3, and I want that. Well, I suppose I should be a bit more precise. The side opposite the 30 is our x. The side opposite the 90 is our 2x. And the side on the other leg is the x radical 3. Now that's very helpful, because that tells me that x is 2. And so a is twice that. A is 4. Does that almost make sense? I hope so. Time to play What Kind of Special Triangle Is That? What kind of triangle? And your choices are 30, 60, 90, 45, 45, 90, or neither. Those are your choices. And so here we go. 3 radical 2, 3 radical 2, 6. Well, I have some hope that it could be a 45, 45, 90, because those two sides are the same. The question is 3 radical 2 equal to 6? Because the hypotenuse of a 45, 45, 90 is what you get when you do leg times radical 2. And in this case, sure enough, it is. And so I say that this is a 45, 45, 90 triangle. And of course, those are all degree symbols. Those are all degree symbols. Well, what about 21, 21 radical 3, 42? Is that a 45, 45, 90, or is that a 30, 60, 90, or is that neither? Well, it's not a 45, 45, 90 because these two sides are different. And I have some hope that it could be 30, 60, 90 because this is the x and this is the same thing radical 3. So the question is this the 2x? Is 2 times 21 equal to 42? And the answer is yes. And so I do have a 30, 60, 90 right triangle there. So first we look for 45, 45, 90. That's easy. If two sides are equal, then we just try the radical 2. And if two of the sides are the same except that one has a radical 3, then we look for 30, 60, 90. Okay, one more thing. Let's do the dreaded square problem. This is a baseball diamond. It is 90 feet on a side. Here's home plate. The catcher is going to throw the ball to second base on a line. I want to know how far it is from home plate to second base. That's what I want to find. I want to find the distance from home plate to second base. That's the unknown. What do we know? We know that this looks like a 45, 45, 90 right triangle because both of those sides are congruent. And so I know that the hypotenuse of a 45, 45, 90 right triangle is leg radical 2. I can say that right off the bat. I know exactly how far that is. I don't have to use the Pythagorean theorem. If I did, if I said 90 squared plus 90 squared is x squared, so 16,200 is x squared, so x is the square root of 16,200, I'm still going to get 90 radical 2. It's not wrong to do that. But at the same time, I want us to recognize that if you have a 45, 45, 90 triangle, the relationship between the sides is much easier to find. Okay, so when we come to class tomorrow, we're going to practice 30, 60, 90, 45, 45, 90. I'll answer your questions. I hope you have them. We'll see you then.